Okay, we are live. Time to get to work. Have a late start today. Streamed pretty late last night and then just crashed. But we're good now. And you can't take a morning off, it seems, because the field will do stuff. We've got this awesome sim from Eugene's lab to look at. GPU drive, GPU accelerated 2.5D. Multi-agent driving sim. Over 1,000,000 FPS. This looks very nice. So I think what we're going to try to do today is we're going to see if we can make this thing. Oh, there's the stream. We're going to see if we can make this thing work with PufferLib. Let's get started. Don't need this. And I will also say that overnight we had some nice progress. Just before you get started on GPU drive here, we did have some very nice progress overnight with some of these training runs. You can see Qbert. It takes a little longer for Qbert to get started, it looks like, but no, we do have some decent runs here. This is the good one up here. And we have, I think Beam Rider was really good. Yeah, Beam Rider's really good. And I haven't even seen this one yet. This one is halfway done on Space Invaders, I think. Yeah, halfway done on Space Invaders. Oof. Look at that. You can see the trend. It's very nice. Okay. Let's do, oops. Let's do this properly. Where's Eugene's thing? Where's the GitHub? Here it is. GPU drive. 3 hours ago. That means we're 3 hours late. IPPO, perfect. That's what we have. And, ooh, they don't have a package. Guys, you really need to have a pip package for this if you can. No pip package. Oh, do they have? Okay. Well, we'll start from here. Do I want to do this local? Or do I want to do this on Puffer box? I should do this local just in case. Unless we lose connectivity or something. Docker. Let's get into our container. Didn't finish watching last stream, watching from Europe. Welcome. You're not obligated to watch all of the streams. There's always new stuff. Have you succeeded with the ELO? We have a nice implementation. I need to probably add some policies to it, but I'm pretty happy with how the implementation is looking. We're doing something different today because there's this awesome release from Eugene's lab. They have a really fast driving sim. I was actually tempted to make one of these, but it looks like he's gone ahead and done it. This lab. So we're going to see if we can get day one support in Puffer, which I hope we should be able to do. This thing could use some squash commits and maybe a pip package. Let's see. Dataset. Simulator. GymEnv. Perfect. They just have a gym wrapper. I don't know how it's a GymEnv though if it's... Gym is not multi-agent. So we'll see how that works. And from there, we have stuff to do. As soon as this finishes cloning. It's stuck? Oh yeah, there we go. Oh right, it's got submodules on it. But yeah, I see the stream is warming up. So for the YouTube folks, today what we're doing is we are adding bindings for this awesome driving sim. Apparently it's very fast. And my goal is going to be to get this working, which is going to be the tough part. I don't know what stuff is under the hood with this. And then I think the easy part is just going to be making this thing stupidly fast in Puffer. I bet we can beat whatever thing they have on this, speed-wise. If the question is going to be how fast it runs on CPU, because the goal is if it runs at like 1,000,000 on GPU, and we're trying to train at 1,000,000 steps per second, that's half of your time gone. So if I run this on the CPU cores and get the data to GPU fast, then potentially I can do way better, which would be really, really funny. But I've seen it happen before. I'm a little bit concerned about the API compatibility stuff because they say it's a gemenv, but it can't possibly be a gemenv because it's multi-agent. We'll do some fun stuff with this. So we've got this thing now, GPU drive. And what do they say? How do we install this? Conda E. Linux and Mac OS. This is not bad, right? Let's see. Some C++. This is with the Madrona engine. Madrona is like this GPU game engine type thing. GPU environment engine. Which is kind of funny because I'm pretty sure with Puffer, you're no longer going to need to implement M's for GPU. It's perfectly fine if they are GPU. But we can make it fast either way. There we go. Okay, so this is just setting up Madrona. Wait, why can't I find her Twitter? Why can't I find Twitter for this? Should be in my retweets, right? Set. Jeez, you have to type this much in order to get the name to show up. That's ridiculous. I've also got to say, it's pretty awesome what we've had with Puffer, just while this is, yeah, 757. That's crazy. Okay. So we have this built now, apparently. Is there a test? PyTest. Can we just PyTest this? The fact that I do not have PyTest installed. Oh, I do have it. Does not work? Well, probably this is good, right? Okay, so it supports... There's human data as well, which I don't think we're going to play too much with because we're just going to do IPPO to start. And we're going to try to make that stupidly fast. Let's see, where are their docs? Intro tutorials. GymM demo. I probably want this, right? So... you can import... Okay, there's quite a bit of stuff here. Torch and Jack's Gymnasium interface with the simulator. I'm a bit confused how they do that because it's single agent. Make env. You pass it a bunch of configs. And then agents. This is probably like a Gymnasium vec interface then, maybe? Episode with n parallel environments. Okay, this is not that bad. I think we can get this working pretty quick. Let me start by making a standalone, and then we'll add this as a binding. Is this gonna work from here if this is not as a pip package? Oh, they do this. I see. They actually have to do. Yeah, that's slightly a pain. We'll have to move. How are we gonna do this? I think this was the case for Nocturne too. I'd really suggest if you guys can get a pip package together. Otherwise, I'll just have to set the paths or something. It's not that bad. So, let's see. Puffer. Player streams while working. Hard to find any valuable dev content. Everything is web or game dev. Great for someone not in the field to go get over. Yeah, I mean, hi. I'm glad it's useful. This is kind of game dev, except that the games are for reinforcement learning agents to play. Okay, let's just make our little test file. Copy some of this stuff. Get this out of a notebook for now. Thank you very much, copy paste. Wait. Working dir if raise. This one goes up here. And then, yeah, we're good. Okay, that's that code sample. We'll get this GIF. I don't think this will work because we're on WSL, but... okay, that definitely did not work. I see. And this display function, where does this come from? I don't see this display anywhere. Okay, so they have some constants. I'll put these up here. Initializing environments. GPU drive GymEnv class and base env torch env and jax env. One exports torch tensors and the other jax arrays. So this is not actually Gymnasium API, it's just Gymnasium-like API, and we're gonna have to wrap it. which is mildly obnoxious because we actually have to get the data out of from NumPy and then back into Torch, but whatever, that's fine. So we have scene config. And env config. Oops. This actually gives us the action space, doesn't it? Yeah, there's going to have to be some wrapper stuff going on. This is not exactly a gem interface. And then a render config. This is the environment. They do torch by default. That is a good sign. No more jacks. And then here's their parallel envs. Really wish I knew why copy paste is this screwy. But whatever. Not a big deal. And perfect. We can actually... We're not going to need this display function, I don't think. We can save this here, though. We can actually do... Import CV2. Sure, whatever. Let's try this. It's doing something. Range. What's episode length? 90. I'm confused as to whether this is doing anything. Okay, let's see where it's stopping, because it's getting hung up somewhere. 21? Really? Oh, geez. It just goes... This is... this is funny. Yeah, it's funny. Set working directory to the base directory GPU drive. Base directory GPU. Do I want to change the working directory or do I want to symlink it? Did I do that backwards? I always forget what order it is. Yeah, it's ln. Okay, perfect. Should not need to set the working directory now. Still no module pi GPU drive. GPU drive. Okay, so this works. So I think it's actually GPU pi GPU and GPU drive. Try this. Okay. Maybe this works. Just sim linking to it. Line 7. Ooh, no module GPU drive. Okay, so this thing is really not designed to work in a different directory, which is mildly annoying. That's okay though. Oops, let's go back to okay, let's see. What do we think we are? Puffer tank / GPU drive. Do you need to have like the poetry install or something? Is there a setup.py? There is a setup.py that we didn't run, right? Oh wait, no. What about the toml? Is this thing installed correctly? Like, oh, there is a pip install, right? That's bizarre. Cannot import. Weird, very weird. Okay, I think there's something wrong with the build. We definitely need to get this working without this, like, path shenanigans. What's in the toml? Tool.poetry. Ah, it actually does have to be poetry. Fine, we'll do poetry. They have the tool. It tooled for that. That's where the missing file was. All right, my bad for wanting to use my own tools. I just did it again. Just reflexively. Really do not like poetry, though. Why is it adding CUDA packages? I already have those. I don't think that this works. You can't just make the package because it doesn't give you the links, right? Oh, wait, add. It says that you should be able to do this. So this was supposed to work and it didn't. That's weird. So I guess I'll try both of these. This is always the bothersome and boring part, right, is getting the thing actually installed correctly. And then hopefully, I'm hopeful that this should be fairly quick after that to get running and then get integrated with Puffer. It's going to depend how heavily they different they well, how much they diverge from the Gymnasium API, because it's not, they say they have a Gymnasium interface, but it's not quite a Gymnasium interface. I assume that they mean they have like a Torch Tensor Torch Tensor Gymnasium Vec interface. So if that's the case, then I'm going to have to take their interface. I'm going to have to wrap it with Puffer, get those into NumPy arrays on CPU, and see how fast I can get it running. Multi-core. This thing not done? Oh. It is. It's just like did something weird. We'll see if it works with poetry. I'm hoping it works with just this. This manual install should be better. But I was getting like a link error with this. It didn't link the package correctly. Let me see in the meantime if I can figure out how this works. Uh-oh. Is the stream down? It's just slow, not down, right? I'm getting a lot of dropped frames. Yeah. Stream will be back up if it's still on as soon as this blip is over. What in the heck, though? Yes. Wait, the stream looks like it's still alive? So hold on, I think that it's just... Is it just that poetry's eating all my bandwidth? Is that what's happening? Let me check on my phone if the internet's down. Seems fine. And I see the stream still being up here, so I'm gonna give this a second to finish downloading, and hopefully then it stops eating all my bandwidth. Last time I tried poetry for anything, though. It's so weird. I definitely have internet. Okay, so will these load? Tutorials? Looks like it. Controlling road objects. Yeah, okay, this actually doesn't look too bad to get set up once we're ready. And they have good versions of everything as well. These are the versions that Puffer uses as well. These are just the latest versions of everything. So we should be fine. So I'll wait for Torch to finish downloading. I think that literally all that happened is that this just poetry just ate all of our bandwidth and took the stream down for a second. It looks like we're good now. So welcome back, folks. We're going to give it a second to finish Torch. I think it just did like some crazy multi-threaded download and just took took all the bandwidth. So I'll go over my plan while I'm waiting for this. It looks to me that they have a multimodal action space, or a structured action space, I should say. I think one of the tutorials had what it was. I hope it's not mixed, discrete, and continuous. Let me see. What environment? This is GPU drive. It was just launched today by... Where the heck did it go? Just launched today by Eugene's lab. And we're going to try to make it very, very fast. So it looks to me that they have... It looks to me like they have continuous steering and acceleration, which is pretty easy for us to handle in Puffer. Haven't done much with the continuous environments. Jeez, okay. Can we... Still doesn't work. Cannot open shared object file. I see it right here, don't I? PufferLib GPU drive build GPU drive.cpython dot. Oh. That's weird. It built it with 310? Hold on. Include CPython 311, but I have Python 311, right? Okay, let me try this let me try the make version again. The from source. They do have Python 311 pinned here. Oops. It's crazy that they actually made this thing build on Windows. Let me make this work first, and then I think if I just do... Import error. Created wheel. Stored in directory. Okay. We'll go back to 311. And it clearly is right here. It's generating for some reason. I don't know why it would be generating like this, though. Why was it generating with 310? Yeah, it says linked shared module. Could not find... Can I just rename it? What if I just do this? Okay, it looks like it imports. It's like fault. I'll make them an issue on that. Madrona was not compiled with CUDA support. Okay. How do I run Madrona in CPU mode? Because I want to do that anyways. Just like this, maybe? Oh, look at that. We got it running. Not bad. Make an issue for him. We're going to get them lots of nice stuff on this today. Oops. GPU drive. Welcome. But this works. Right? You can see we have the car. It runs. It does stuff. Now we get to do some benchmarking, right? New to Python. Well, this is going to be a bit much then. We are doing high performance reinforcement learning development. Today, a new GPU accelerated driving simulator released from some buddies of mine at NYU. And they are doing, it looks very good. So I'm adding a binding to PufferLib so we can train neural networks to drive cars fast. Or well. Yeah, this is the environment we're playing with right now. It's a GPU driving end. These are cars. Just started on porting this. Well, yeah, that's the plan for today. So first thing I want to figure out, how many cars are there in here? Ten by 128. That is weird. This is nice. What libraries? My main stuff is in PufferLib. Here are the docs. Repos right here. Put it in the chat. Open source high performance reinforcement learning. Try to make everything very simple as well. Why do they have 128? Ah, that's why. So is this 128 per scene? Oh, it's because, yeah. So there's, this scene is large, right? Num worlds. So 10 worlds up to 128 objects. It's actually kind of hard for me to tell how I should be looking at this. I don't know. If I do this, if I do one, is it going to be totally different? Is this going to be a different map? Yeah, totally different map. But I only see one car. Right? I guess it's like faults if you don't close it properly. But I only see one car here, which just disappeared. I'm not sure how to... Well, let's not abuse this thread. I'll tweet him. What I understand, you're simulating cars and trying to find the best path for it to move. Something like that. This is not my environment. This is just released today by NYU. What I'm trying to do is I'm trying to add support for this into PufferLib so we can train RL to do probably what you just said at very... Well, we can do that very fast and easy. That's the goal. Video frames per second is 4. I cannot test how fast this is as is, though. It's annoying. And we'll be able to do that later. I think for now... Basically what Tesla AI does. Sort of. Much smaller scale. But yeah, kind of. You believe you can do it better? Man, if you want me to do what Tesla does but better, I'll please give me my pick of like 1,000 engineers from like the 1,000 best engineers I want, and like several $1 billion, and then we'll talk. You can't compete with that number of resources at this scale. Okay. You want to see how funny that is? Actually, this is so Tesla. Do they have a picture of it? Yeah, okay. So this is what their data centers look like. This is what my data center looks like. Little bit of a difference. Little bit of a difference. All right, so I think that we can actually start adding this to Puffer already. There are a few things that are bothering me here. Let's make a little wrapper. They have a, I don't know how many billions of dollar cluster. I have a $30,000 cluster. Where did you learn Python? I think I learned Python when I was like 16 by porting one of my crappy neural networks from MATLAB. So I don't know. Yeah. You just start writing code and you keep writing code until the code stops looking bad. Oh, then you're starting at a good age. That's when I started doing research. This actually should not be a wrapper, right? This needs to be... Yeah, all this stuff needs to go into the class. I don't know. If you're new to all this stuff and you want to do some cool stuff in AI or whatnot, I would just... It's going to take a lot of time, so be patient. And also, just, like, start writing code and don't get too wrapped up in, like, doing fancy object-oriented crap or fancy functional crap. Just, like, write simple code that makes cool projects. Mm. Mm. Okay. So now we have self.env. I want to take a look at the observation spaces here. What just happened? Self.env? Class values must be non-negative. What's GPU drive? Should I just put this up on the side of the stream so that people can see it? I'm just gonna like put Eugene's post up on the screen. Okay, this is GPU drive. This is, I don't have enough screen space for it. But yeah, this is GPU drive. They have fancy driving sim. I have time, done cool projects with some help. Classes suck because, yeah, classes suck. Oh, well, no, I thought you meant like instructional classes like lectures, but yes, those, whatever. No, this is supposed to be a million step per second environment. We're going to see how much better we can do. It's a GPU environment, My plan is to run it on CPU multi-core with Puffer so that we don't waste the GPU time on the env and we use all the GPU time for the network. Since we've got like a newer person to stuff here, I'm just going to make one small detour comment. If you just want to see like how far you can go in 10 years, this is some of my like absolutely garbage work from when I was 16. I think I'm 16 in this photo. This is like me training really, really bad like neural networks on ConvNets or whatever. That's also me at 140 pounds. Yeah, there's like some neural network stuff in here. But yeah, this is some of the stuff I built when I was way younger. Takes time. How many SPS are you hoping to get out of it? I don't know. We're going to see how long it takes. More than what they currently have. Whatever they have at the moment, I want to get it to be faster than they have it. What happened here? I literally just pasted this into the class and now it no longer works. That's weird, isn't it? Yeah, no worries. Did you call the class? Yeah, you'll see. I mean, if you just hang around, you'll see some dev. Okay, so here's our environment. Okay, so it does have a proper observation space on it. But I don't think it's the correct observation space, right? Yeah. So if I do like this, you see right here that this is not what was given. They say it has 30... Oh, wait, no. Is this right? It's not exactly right. Because they stacked it weird. This needs to be reshaped. This needs to be reshaped. And what did they have for action space? Discrete of 9. Really? Discrete of 9? That doesn't look right, does it? Steer actions. We using panda? No, there's no pandas. So this is reinforcement learning. This means that the data comes from a simulator. This data is generated in memory by interacting with the simulator. So you do not need any tools for interacting with large data sets. What you need is ultra high performance ways of getting gigabytes of data per second from multiple CPU cores onto the GPU, or you need ultra high performance ways of, generally coupling this back and forth. Simulator runs simulation, simulator returns data, neural net acts on data, neural net returns actions to simulator, simulator steps forward. That is the loop that needs to run fast. I have no clue about what you just said. Good. It would be kind of weird if you did. I'd be very impressed. I would be very impressed if you did. If you're trying to pick up machine learning, though, I would highly suggest, yeah, I will repeat that slower since other people are confused as well. But if you're trying to learn AI stuff, I would highly recommend CS 231N. The lectures are online. Stanford course. It's a grad course, but it's a very accessible grad course. That's where I would start. Yes, let me repeat. So the way that this works in reinforcement learning, right? Reinforcement learning is not like supervised learning. We don't have a big data file with 10 terabytes of data that we then need to load off of the disk and like manage and get into the neural network. That's not what we're doing. What we instead have is a simulator. It's like a game. In this case, it's not a game, it's a driving sim, but same thing. And what we're going to do is we're going to run many copies of this simulator on different CPU cores, okay? And they're all going to run at the same time. So what we need is we need a really fast way of getting all that data from all those different cores to the GPU. They have to get onto the main process, and then they get onto the GPU. That's a lot of data that has to be processed very, very fast. We're talking like you have a few microseconds that you can waste here, but it has to be very efficient overall. And then that data, once it's on the GPU, is run through a neural network. The neural network tells all the cars what to do, where to steer, how to accelerate, so on and so forth. That data gets sent back to all the different processes. And then the simulators step forward using that information. They say, okay, the car is going to go this way. And then they return more data. That process has to be very fast. That is what PufferLib does. Hi, is it possible to create a StarCraft 2 AI like AlphaStar using the reinforcement learning resources you have? The closest thing I have for you for that is on my Twitter. The main project I was building at the one of the main projects I'm building at the moment. Where's the GIF? We've got a MOBA. It's not AlphaStar. It's closer to Dota. But I've been building this. This runs at like 1,000,000 steps per second per core, so we can actually train this with the resources I have. We're not going to be able to train on like StarCraft properly just because the game is too slow, but you could very easily do a project, well, not easily, but with about the same amount of effort, I could have done like an RTS instead of a MOBA and had something like this as well. At what point did you get into RL in your ML journey? Practice it. So RL is, I've worked in vision. I've worked in natural language processing. I did both of those for about 3 years. Reinforcement learning is much, much harder. Not from a math perspective, not from a research perspective necessarily, but from a pure engineering perspective, because you have this giant additional stack of tools that has to work with complex simulators. So 80% of my work is engineering, building this type of stuff. That is what makes it hard, but you still have to know all the other stuff in ML. Now, the nice thing is that I'm fixing this. I've only been on this now for 3 months since I graduated my PhD. I've been doing reinforcement learning for like 7 years, but this is where I finished my PhD and started working on PufferLib full time. This has been the growth on the project in the last couple, 2-3 months. So we are very, very quickly making reinforcement learning fast, simple, and easy. Also much harder in theory. I think it's harder than everything in supervised learning, except for the infra engineers who have to do the multi-node scaling on like large language models. The multi-machine scaling infrastructure is probably as hard or harder than this, but everything else, no. RL's hard. The nice thing is we do kind of have unlimited data, so we don't have to worry about overfitting and regularization and stuff as much. So that's nice. But we have every other problem in the book. Okay. Let me figure out why the heck this thing wasn't working. Oh, you were actually right. I forgot to instantiate the class before. That's funny. I wasn't paying attention. That's actually so funny. $38. There we go. Now, what we have to do is reset. This is fine. Match API, def step with action. And we'll see what this returns. I don't know if it has a step function. It does have step. Let's just see how what this does. Was not really until RL that you started going hard into the engineering aspect. I mean, the engineering side has been relatively recent. I did a lot of simulation development for Neural MMO that involved a fair bit of like engineering and components and stuff. But the ultra high performance RL is something that has happened since I graduated because it's not something that you can really work on well in academia. Um, so this is a relatively recent thing. That said, it's been going incredibly well. Like in 3 months, we have simulations that are 100 times faster than everything else. Mm-hmm. It's funny because I never really liked low level engineering when I was in college or whatever, and I still don't. But the only reason I don't is because of fiddly tools that make it impossible to debug stuff. With the current stack of stuff I have on Puffer, it's pretty painless. I can just like write super fast stuff, right? Because obviously, like, I know how to do all of it, right? It's just a matter of having an interface for it that doesn't suck. We do all sorts of stuff for the simulation code in Puffer though. We do like there are zero dynamic memory accesses. We have like all the memory pre-allocated for the sims. We do occasionally we'll do stuff like flat circular buffers so that to avoid copying data around. We do a lot of like memory views between Python and Python, so we have zero copies that way. We'll do stuff like we'll simulate everything inside of shared memory so that you actually don't even have to like copy the data around to get it off onto the main process. Lots and lots of big optimizations. Is that why you use Python? Yes, Python is awesome. Do you do the simulations in Puffer? Puffer has some first-party simulations that I have made, and it also has optimizations for other environments as well. Some, depending on how fast your environment is, like generally the faster your environment is, the faster Puffer can make it, if that makes sense. Like if your environment is slow, then there's like really not anything to optimize because it's really easy to handle tiny amounts of data. But as your environment gets faster, Puffer makes it even faster. So there's a compounding effect. Like it's going to be very, very soon that the standard for reinforcement learning is your M has to run at 1,000,000 steps per second, and there are going to be lots of M's that run at 1,000,000 steps per second, and training is going to be at hundreds of thousands to 1,000,000 steps per second as well, all because of Puffer. And a few other niche groups as well that are like doing cool stuff. Like this group here at NYU is awesome. Oops. What happened here? Sig fault. This needs a bunch of API garbage, doesn't it? What does Puffer do to speed the env up so much? Vectorization. Most environments, it's very hard to get. Let's say your environment runs at 1,000 steps per second, right? Or no, more than that. Let's say it runs at like 6,000 steps per second, right? And you have 16 cores. Like the default vectorization will run at like 10,000 steps per second. That's what the rest of the field will use. You get absolutely terrible scaling. Puffer gives you good scaling. It gives you a lot more on top of that. But that's one of our killer features. Is like really, really good scaling. Not implemented error. Oh, that's weird. That's fine, though. We'll just do like this. Okay. Didn't know this sort of computing wasn't vectorized. Oh, well, they try to, but they do it very slowly. I tried running demo.py with the forging in profile mode, but I got an error. Do I have to do additional stuff? I might just have a bug in it. If you paste the error, no, I can debug it for you real quick. Nice. So we got this running. Would be puffer wrapper. And we have to do def render of world. We can just run this now, can't we? Yay. And runs. If the whole training loop can be compiled, well, then it doesn't do anything, Relu, but, like, that's not going to be the case ever for everything. Like, you have to write your entire sim to be GPU, which, like, okay, look, they've made this thing for GPU, but how much work do you think this took to do on GPU? Like, how much less work do you think this would be if I wrote it for CPU, right? It's like 1/10 of the complexity to do stuff for just CPU. Like, if I were trying to write the MOBA for GPU, I'd be doing that for months and months and months. And also, GPUs are just not good in general at doing arbitrary logic. Like, that's what CPUs are for, right? GPUs are good for lots of dumb, samey parallel operations. So, it's way smarter, in my opinion, to just bet on sims having to be, most sims being on CPU and making that really fast. Like, the reason that people came up with these fancy GPU sim frameworks in the first place is because how stupidly slow it was on CPU, not because CPUs are slow, but because the code stack was bad. Error I get is, let me fix that for you real quick, Noah. be? I think people moved M's to GPU because GPU is like having a lot of CPUs. It's not though. Do you know the restrictions behind GPU? Like, have you looked at like the jack scan operations, for instance? It executes all possible branches of your code at every step. It's really hard to write arbitrary code on that. It's like Vault. Try this. Because it probably just didn't compile the snake env. I think this runs. There you go, Noah. I just, I'd forgotten something in the port. So the way that function works, like, you have to set it for, like, a short train run, and then you'll get stats on that train run. I would generally suggest that you probably want to profile the env itself, not the entire train loop. And there's, like, there are little profiling snippets in most of the M's that you can use for that. Jax meet VMAP with conditionals also. Yeah, that's what I mean, JBL. It's really janky. Most of the time, it's like, why would I spend so much effort getting something to run 1,000,000 steps per second on a GPU, which is the big expensive piece, right? When I can make it run easily 1,000,000 steps per second on one CPU core, right? It's like, oh no, the infrastructure is so hard in order to get that data onto the GPU efficiently. Yeah, but Puffer does it, and our whole stack for doing that is 1,000 lines. Just nobody bothered to do this, right? Puffer does it, now it works. Okay, so this works. Now we have to make this Puffer environment compatible. So what we're going to do is, how do you get 1 mil steps per second on a single CPU core? Very easily. Just by not writing unoptimized garbage Python. Like any of the, you can look at the source code of any of my environments. They're very simple. They're single file Python. They're just single file of Python. It runs pure C. But it's a lot easier than writing pure C. I'm pretty confident at this point that I can implement practically any environment out there, like any type of game env I want. I can make like a reasonable version of at several 100,000 steps per second, guaranteed, 1,000,000 steps per second probably, and in many cases, many millions of steps per second per core. Like, I don't know, I was playing Slay the Spire the other day. I could make that game run 1,000,000 steps per second if I just implemented it like this, right? Do it for whatever I want. Python is slow. What about robotics? Yeah, if you need a physics sim, that is the actual use case for GPUs if you need an expensive physics sim. Pretty much everything else though, nah. So that is with no parallelization? Yeah, you can get 1,000,000 steps per second without any parallelization. It depends what you mean by parallelization. If you mean multi-core, yeah, without multi-core, just one thread, you can do that. I do end up running multiple copies of the environment per core for convenience, but I can still get it to be pretty darn close to that even without it. In fact, if you just get rid of the loop overhead from Python, you still get a million per second. Nothing fancy. Really, there's nothing to it. And go read like the snake code or the MOBA code. There's nothing crazy in there. False. Okay, so I need to get these obs into a reasonable format, right? Class values must be non-negative. What did I do? Huh? Oh. Are you not allowed to put a breakpoint there? You should be, right? Oh, there we go. That's fine. Obs, numpy, reshape, num worlds, times objects, size. Let's work. Nice. So there is significant performance increase with Puffer just running one copy of an environment? Okay, you're conflating two things here, right? There are Puffer's first-party environments, which are the environments that I've written to be fast, right? Those environments are going to be fast uh, on their own, but then if you try to run those vectorized with other vectorization, like Jim's vectorization, that's going to be slow because their vectorization implementation is bad. So in order to have many copies of the environment on many cores be even faster, you need PufferLib's vectorization. So in a way, PufferLib's vec enables PufferLib's environments. Now, if you just hand me any old arbitrary environment that's slow to begin with, garbage in, garbage out, I can't make something that's slow any faster. But if, let's say, you have a reasonably fast environment that's being bottlenecked by Jim's really stupidly slow vectorization, then yes, PufferLib's vectorization will make it faster. The limiting factor is Python itself. Well, yeah, Python's a slow language, right? You can't write a simulation in pure Python and expect it to be fast. Like many of the simulations that researchers use are just garbage unoptimized Python, and it runs at like a few hundred steps per second. Like I can't do anything with that, right? The easiest way for me to fix something like that is to throw the environment away and rewrite it in Python, and then it'll be a million steps per second. This one here is an exception, which is why I'm using it, right? This is a really fast one. Cool, so this still works. NumPy. Located. What are these duns? Are these torch tensors? It should not be done on step 1. That's really weird. Nice. Okay, so this is actually getting pretty close to being usable already, believe it or not. I'm sure there's a little bit of API shenanigans we've forgotten. But this now returns... We need num agents, right? Yeah. Self.num agents. I want this the other way around. Alright. And then we'll do like this. Agents. I'm surprised that there's no infos returned by this thing. Random action is actually torch.tensor. This actually, is it a discrete action space? Am I reading this right? Guess so. Kind of weird. I'll ask him if that's intentional, but... So here's our code. Don't really need this display GIF function. I'll just put this down here for now. Where do I put this? Nah. Whatever. Let's grab all this code and let's dir GPU drive. What are we gonna copy for this? Yeah. GPU drive. Okay, so this is just code that we copied from before. We can get rid of all this garbage. This is just from, these are all the first party M code. I just copied this as a template. Okay, here is our environment wrapper. So we've got env creator. And this can return, I think this just can return this can just return puffer CPU drive, right? It can just be a class. We'll put puffer here. I don't know if we need this worked or anything. I hope we don't need this anymore. We will put these constants down here. Whichever ones we're actually going to use at least. Not used. Scene name. Not used. Unique. Yep, this is used, and these other ones are used, right? We might need episode length. We do not need this. We do not need this. Torch. We do need torch, which is a little bit obnoxious. And we need puffer, of course. Everything is better with puffer. Okay. So we have mcreator, puffer CPU drive, and now we have to add a binding to PufferLib. What is wrong? Why can't I type? There we go. Copy config, ocean. What we say? We copy like the snake config. GPU drive .ini. Okay, we have some stuff in here, right? GPU drive. GPU drive. Now we have a config for it. Is that it? Data does not exist or is empty. So I assume that we need this annoying, this change dir. That's a little bit silly. Oops. It's a little silly, isn't it? No dim. Actions is not none. Ah. It is in 73. Right, this has to be a torch tensor. It's slightly annoying. Doesn't need to be put to GPU. Puffer is a CPU library for now. No attribute dim still. Oh, action. I've gotten this error before. Invalid action shape. Shape. What did we say the hold on. What's the shape of the action here? Num worlds max num objects. Okay, so we do actually have to reshape it. Slightly annoying. No big deal. So that is an error in the thing itself. Come on. GPU drive error. Lol, it works. Haha. Apparently this thing is running. Cool. Didn't expect it to run that quickly. Cool, I guess. Let's go look at their networks and like add a reasonable network, and then we'll do optimizations and make this thing real fast. 60% env time is concerning. But we'll see. GPU. That's so funny that Eugene actually, like, manages the bug issues and, like, assigns grad students to stuff. That's so funny. uh, that's so funny. Where's the network? Policy actor. Agents policy actor. Do you have documentation of all the out-of-the-box optimizations? If I want to write my own env in Python. The way to think about it is that just Puffer's vectorization is really, really fast. So it's not going to cap your speed of your environments to be way lower than it should be. If you want a comparison or you want convincing, yes, there's a white paper. There's like a good page here of optimizations. And there's also, there are some perf tests on stuff. The perf actually has gotten way better since then because, like, the environments weren't even fast enough for me to show how good Puffer is, if that makes sense. Because when you get really fast environments, that's when you really start to see existing vectorization implementations just chug. I guess we kind of did, right? We had like 4 million versus 100,000. That's like a good example. Yeah, they just chug. Okay, we're going to look for their agents in here. Please don't be gigantic. Wait. Huh? Where's your network? Where are your policies? Give me a policy. Demo? Oh, there was a .py. I'm just dumb. Oh, no, they didn't have it up there. Okay. Where... But, like... Policy actor... I'm so confused. Saved model, trained policy path. Model, learned SB3. Where's your implementation? Oh, it's freaking SB3. Oh, that's hilarious. Wait, if this is SB3, then I'm going to be way faster. Are you planning on implementing any GPU acceleration? The thing is, you don't need any of this. If you have GPU acceleration, like, you don't need parallelization and stuff because all your infra is fast and it's easy, right? Like, the thing is that you put all the difficulty into writing the sim. It depends how complicated your physics are, though, right? Like, we have stuff with continuous control now. If you have really heavy physics, then yeah, you're probably going to want to keep it there. But if you're just like, if you have some like light physics stuff and it's not super fine grained, like it doesn't run a bajillion times per second, then you can probably just do a CPU env and have it be faster with Puffer. You got to remember that your network is supposed to train on the GPU. So anytime you're running the environment on the GPU is time that you're stealing from your policy, right? So if your environment runs 1,000,000 steps per second, well, you're not going to train more than like 500,000 steps per second, right? Because your network's going to take your network's going to take half the time, and your environment's going to take half the time. And Puffer's just going to keep getting faster as well. We have like optimizations, more and more optimizations coming for CPU stuff. So like ultimately, it's just going to be. I think that this just wins. Doesn't mean that environments like this aren't useful though, because I can just run this in CPU mode, and it's still going to be fast. And, you know, if you want to not deal with Puffer's whole stack of stuff and you want a really, really simple thing, then yeah, you know, you can just run it in GPU mode. But I think it's going to be less and less necessary to have to suffer so much in order to get this level of speed. That said, this specific project is really, really good work. I'm excited to make it even faster for them. See, thanks, bro. Yeah, no worries. We're having good times with this. If you haven't already, go ahead and give PufferLib a star if you find any of this useful. Helps me out a whole ton. We're at 758 right now. Huge amounts of progress. Where's their thingy? And has Eugene replied to me? Oh, Daphne did. Max cont agents determines maximum you want to control. Since number of different vehicles can be controlled, 10 may result in you controlling 5 agents and 1 and 9 in another, up to at most 10. Ooh. That might be a tough one. That might be a tough one. Thank you. If you're not doing proper masking, that's going to create problems. Luckily, Puffer does have a masking feature, but we might have to do some modification of stuff in order to make this go zoom. Is it in baselines? Probably in here, right? SB3. Yeah, this is painful having to do this with SB3. Where is their MLP class? Policy is expconfig. Where's expconfig? ippo.config. Late fusion net and late fusion policy. Networks perm EQ. All right. Down the rabbit hole looking for this. Aha. Perm EQ late fusion. What is a late fusion architecture? Am I just dumb? Am I just dumb for not having heard of this? Late fusion network. What? Is this something really obvious and like really common that I've just never heard of? Fusion of different modalities. No, that's something different. All right, let's read the code. Build network. Oof. Yikes. They got a lot of stuff. Doesn't look like they have anything fancy outside of that, though. So they unpack this, right? Batch size num objects. That's hard. I'm afraid this network is just going to be slow. The main problem. Oh, wait. Up to at most 10. Hmm. Pufferfish go. Pufferfish go. Absolutely pufferfish go. Puffer go moon. Build out network is they do linear, layer norm, dropout. Linear layer norm. I do not believe that that is a good policy. I'd have to read their paper for ablations, but I do not believe that is a good policy. Long time, everything. Yep. Doing well. Lots of progress being made here. We're currently adding bindings for this. Where is it? Where's this thing? This awesome GPU driving sim. Adding this to PufferLib. And we're going to see if we can make it really fast. I'm trying to figure out how much of this I actually want. Gee. I think that, ego state road objects road graph, right? I think this is like the stuff that I want. Let's start copying this stuff in though to the model. Not gonna get anywhere by messing around. Do we use the snake M to start? Yeah, we'll use this. Policy. Your work and personality are inspiring. Hey, I'm glad you find my stuff interesting. It is all freely available right here. You're good. But day one support for a sim like this is going to be real cool to have. You're going to be real cool to have. Ego state dim. Yeah. I think what we really just care about here, and it's so funny to see them do this because this is what you do with the Puffer Advanced API, is you basically do this exact thing, and they've done it for me. But I can tell that this involved a lot of pain and suffering, and there is a much easier API in Puffer that prevents pain and suffering that would let you do the same thing. So we'll use the Advanced API and make it really fast for them since they've gone to the effort. But you know, much pain and suffering could have been saved. Definitely much pain and suffering could have been saved. Can we save me some pain and suffering with this freaking terrible copy paste? Jeez. I don't know why it does this. The killer feature of VS Code is not like anything that NeoVim doesn't have. It's being able to actually copy and paste stuff. Imagine being able to do that. Just gonna do this for now. Unflatten road objects. So we have all these like config thingies. Where's their config? I think it's baseline's config. Yeah, this thing right here. So, okay. Num world is going to be 50. We definitely want this file. It's pretty cool that they have their lab is called Emerge Lab. That's fun. Oh, they even have hyperparameters for us. That's very nice of them. I really hope we just solve this environment today. That'd be just so funny. Ah, they actually have a very tiny little network. Tiny, tiny little network. Look at this. Tiny, tiny little network. Ego state, partner state, roadmap dim. I don't see where this thing is in the config. Isn't it supposed to be here? Maybe if I look. Ah. If ego state. Whew. They have a lot of stuff in here, don't they? Oh, that's so sad that they had to write this in Pygame. That must have been very painful. It's like so funny having just been in this space for long enough that like I know which packages just suck to work with. And like I can just look at the code and just say, "Oh, they had to do this with that." Man, that must have been, you know, several weeks of somebody's life. Oof. The goal is to get to a place where those packages no longer exist and we only have good packages so we can write stuff like this without it being painful. Ego state dim. Where's the config? And baselines. No, it's, where was it? It was in networks. Build your own packages from scratch. I do build my own packages from scratch all the time. I didn't like the Atari renderer yesterday, so I wrote one with Raylib. Okay, so ego input dim. Anywhere we see ego input dim, this is ego state dim. And then this is row input dim. So this is partner dim. It's roadmap dim. Row input dim is partner dim. This is roadmap dim. Doesn't need to be configurable, does it? Roadmap, ooh, this is roadmap agent feet dim. Personal pet peeve, but I do not like types in Python. I do not like typed code. Which would also mean I do not like TypeScript. RO max is roadmap agent. No typing in function signatures is crazy, man. No. Let me tell you what's crazy, man. What's crazy, man, is having type signatures, uh, typing in function signatures that is not even enforced and doesn't make your code any faster. That's what's crazy. When it's literally just there telling you that this is the type and that's not even necessarily the type. That's what's crazy. I like my types when they actually make the code fast and actually do something. Not when they just sit around and pretend to be useful. Why do you need TypeScript? I already type my scripts. I type them with a keyboard. It's for the readability? No. There's, you know what's readable? Readable is what's readable is when there's less code because it's not littered with types. All right? I don't need to know that this is of type int. Okay? I see it says 32. That's the default. I don't need to know that this env is of type like environment. It's called env. We're good. I will gladly use types in Python when it gives me 1,000,000 frames per second. Not in Python where it does nothing. Like, is this useful? I know this is a torch tensor. It's inside of a freaking torch policy, right? I know it's going to return a tensor because it's returning a thing, and it's a torch policy. Oh, we're good. Does this thing need a CNN anywhere? I don't think so, right? We just need hidden size 128, maybe? This is something we'll never see eye to eye on. You can look at my Python code. Like, it's like, yeah, it's typed. It's fine. Honestly, like, the thing is, if I have to type my Python code, like, it's not even worth using Python for me anymore. It's that bad. Like, if I'm going to be typing my code anyways, I want them enforced and I want to have speed out of it. Like, I'll pick literally any other language rather than type my Python code. I'd rather just write the whole thing in Python at that point. I don't know, go pick up some Go or something. That is too crazy, though. I will sometimes type the function signatures for, like, documentation of exposed stuff. Like, if I have, like, a very small surface of exposed code, then sometimes I'll do it so that the autodoc picks it up as well. But, anything internal is not getting... No, it's not getting typed. It's not happening. You can't make me. Now we have the non-deterministic bug. Love me some non-deterministic bugs. Very good. Graph. Ay. Okay. Okay, well, that's mildly irritating. Structured data. Max 1D pool. Max pool across features. I'm confused. I don't think you need this. I think this is literally just a max. Max across objects. Well, this isn't bad at least. Yeah, this is not bad at all. So I think I just come up with a little network for this, right? Ego embed. PufferLib. .net. Whoops. Hidden. Maybe 64. Okay. This is what we wanted. So we just have linear, relu, linear. And then what we do is we do a max. Max. I'd like to figure out how to do that well, but we'll start with this. And then self.proj is going to be from 3 times the input size to the hidden size. Figure me that. Okay, and then we do embed. We're going to make this network so fast. It's going to have memory. It's going to be awesome. Their network does not have any memory, by the way. Isn't that funny? They're driving cars that have no memory. Values indices. Okay. So we do. No, let's not do that. Let's just do it this way. Max dim equals 1. Map embed. Hold on. This one doesn't need max. I don't think, right? Yeah, no, this one doesn't need it. That looks pretty good to me. That looks pretty good. What do we think? We think this is going to train? Once we, figure that's an environment bug. Come on. There it goes. Oh, yeah. We train. We be training. Solid. So do we have an LSTM here? RNN name's got to be recurrent. Let's set some hyperparameters, yeah? So policy name is policy, RNN name is recurrent. And we can use their hypers. They gave us some nice hypers. 0.99. GAE lambda 0.95. Clip coefficient 0.2. Value function coefficient 0.5. VF clip coefficient I think is going to be the same 0.2. Grad norm 0.5 will be a good default. I don't see it. Entropy 001. Learning rate 3e minus 4. Wait, 3e minus... This is 4e minus 3. Did I do it backwards? What was it? 3e minus 4. Yeah. This. Num epochs is 5. Are you guys sure about that? That's going to slow you down a lot. That's a bad sign right there. I'm going to leave it at 1 for now. Any other hypers? Num worlds. Stuff like that. So far, so good. Mini batch size. Let's do some optimizing. In 384. Okay, can I figure out what the heck is wrong with this? I didn't change any of this stuff, did I? Okay, 35,000. 53% on the env. So we didn't even do multi-core yet. What is it that they say they do? 128 by 10? I probably want 4096 per core, right? So let me think. That's 32 M's, right? Seems like a lot. We'll try it for now. This is where we're going to have to figure out that bug if we want to continue, because it's so unlikely that we're going to get a good one. Oh. Really? That's a lot of data. It's a lot of data. I mean, we'll see whether this ends up being reasonable or not, but that's a lot of data. I bet this sim is not going to end up being crazy fast on CPU. I'm going to think if I'm going to do like 24 environments, I probably want 1024 instead. Let's do 1024 environments instead. So we'll divide this by 4. So we'll do 8 worlds. This gives 1024. And this is, let's do like 8. No markers is 8. Do I have an 8-core processor? Yeah, I do. Batch size. It's batch size is the param name. Okay, so what I'm doing now is I'm setting hardware optimal parameters. Okay, that's good. It's about the same as what it was before. And now we do this. Uh-oh. That's taking a while. Stuck? Something's wrong. Well, that's definitely weird, right? Okay, so this is this bug that we gotta fix, right? One hot encode. Can I figure out what this is? Also, let's see if I have any other replies from the creators of this. Oop. I might hop off the stream for a few minutes here in order to do this. Okay. I'm going to hop off the stream for a quick second to do a call. I'll be back in a few. Oh. Unless she is watching the live stream. I'm one of the devs. I'm going to close the stream. I'll be back in a few.